This is our plan of attack.
Banks have become an essential threat to our democracy. So consider this justice.
Thank you for listening to Revolution Radio, freedomslips.com, the #1 listener-supported radio station.
Hold on the internet. 1 second.
Please help support this station so this battle can continue forward. Revolution Radio! The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com.
Hi, everybody. It's Francis with Collision Course on Revolution Radio, freedomslips.com.
Your host.
Good evening. It's 6 p.m. Eastern Time, 5 p.m. Central Time. With me, I have my guest, Dr. Stephen Fuselier from the Southwest Research Institute. Stephen, are you there?
I am there.
Thank you very much for joining us. If you give me 1 second, I just want to tell everybody a little bit about you, and then we'll get into our discussion. Is that okay?
Yes.
Wonderful. Well, everybody, I'm glad you joined me tonight, Saturday, October 6th at 6 p.m. Eastern Time for Collision Course. We have a wonderful discussion with Dr. Stephen Fuselier about the IBEX space mission. Not only will we talk about IBEX, but we'll talk about some of the other research missions he's involved with. I can tell you right now, Stephen's a very educated man who's come to us with great experience and knowledge. He has a BS Physics, University of Southern California, 1981, MS Physics, University of Iowa, 1983, a Doctorate of Physics, University of Iowa, 1984. His research areas include more than 30 years of experience as a scientist, project manager, and senior manager for scientists, engineers, and technicians. He's co-investigator and sensor lead on the Interstellar Boundary Explorer, or IBEX mission. He's the co-investigator and lead for the Hot Plasma Composition Experiment, HPCA. And Stephen, if I get anything wrong, will you just stop me?
Go ahead. You're doing
I'm going to try to get it all right. But if I do say something wrong, feel free to stop me. So once again, he's a co-investigator and lead for the Hot Plasma Composition Experiment, HPCA, on the Magnetospheric Multiscale MMS mission. He's a co-investigator on the Rosina Image and the TRICE-2 sounding rocket. His scientific interests include analysis of space plasma and energetic neutral atom data from various spacecraft, including the ISEE, ICE, AMPTE/CCE, Polar, Cluster, Image, IBEX, Rosina, MMS, CRRES, Chemical Release, and AEPI, Artificial Aurora Experiment. My friends who are listening right now, I know that was a lot of information, and you may not have any idea, but I will go back and cover some of these things after our discussion with Stephen is complete if we don't talk about them. I know it's a lot of information. I'm going to try to focus on just some of the great things he knows. Besides all that work he's doing, he's also authored and co-authored over 390 papers. Let me scroll up. Stephen is the lead investigator responsible for the development of one of 2 science sensors on the IBEX. His specifically is the IBEX-lo sensor. Stephen's work as a plasma physicist who works in space science. Stephen comes very close to achieving his dream of being an astronomer, like myself, who grew up in Louisiana outside of New Orleans. He's always been interested in science since a young man, and he wanted to be an astronomer when he was a young man. As an adult, Stephen was further inspired to pursue a career in space science while working as a graduate student teaching assistant for James Van Allen, and that's an important point. The famous space scientist at the University of Iowa. Let me say it all again. Stephen was a graduate student teaching assistant for James Van Allen, the famous space scientist at the University of Iowa. He was humble, extremely intelligent, and enjoyed telling stories, both good and bad, about working in the field. It was inspiring and quite enjoyable, Stephen said. Because this is a very complex business, i.e. the science of particles traveling back and forth through our solar system's heliosphere around Earth's magnetosphere, and then outward into the inner space medium, you can never dismiss comments. And this is something that Stephen said, so I'm repeating it, Stephen, as almost as your quote. To never dismiss comments from somebody else because you think they're wrong. Try to really evaluate what people say and always realize that you could be wrong on something and just accept that. And it's so important, and I think that's why I led into this, and I'm going to end on that, and then we'll have our discussion, is that in this day and age, Stephen, it seems to me apparently that people like to focus on theories, hypotheses, and pit them against science, and in some way discredit one or the other. And my goal in what I do is to reach out to people like yourself and to bring in the work that we need to talk about and I don't want to say layman's, because we're a force of people who want to know about space. As astronomers, in my case, me and my father-in-law have built remote telescope observatories, and we've really dedicated a chunk of our life, like you've dedicated your whole life, into this interesting science. So putting that to an end, having science be a discussion about pros and cons and theories and facts is something that will go on infinitively, because the universe has an infinite number of answers that will one day may be revealed that we don't have right now. Okay, that's it. I'm done talking. Are you there still?
I'm still here.
I'm sorry. I'm so sorry. So, Stephen, let's get into some of the work that you've done. And specifically, let's work with IBEX right now, because we have an anniversary for IBEX. IBEX has been working out in space, coming up on 10 years in 2 weeks, correct?
That's correct. Yes, launched October 19th.
And I read about the launch, and I know that you were working with the low sensor on the IBEX before the launch even occurred, because you had to, you were a part of the whole process of coming up with the ideas and the working out the science to be sure that the sensor would work right when it finally did get out into space. I have a question about that. Did you go to, did it launch from Guam?
It launched from Kwajalein out in the South Pacific. So, and it launched on a Pegasus, which is a rocket that's dropped from the bottom of a jet airplane, an L-1011, and that basically, so they take the L-1011 up 50,000 feet. And then they drop the rocket off the bottom of it, and in 10 minutes you're in orbit.
Right, because it's the launch point is closest to the equator, so it's the quickest trip from where you start leaving and actually get left. Well, that was interesting. I didn't know when I read that it was a belly drop rocket. I guess I didn't research a little bit deeper. I just assumed that it was a stand-up rocket. Question: where was your location when it launched? Because I know you must have been extremely excited and on edge of all the work that you had already put into it. Were you at a mission control somewhere? Was it in San Antonio?
I was at an orbital. Orbital in Virginia, waiting the launch. Yes, that was actually very exciting. Of course, we had to wait. We didn't really get a lot of video from it, but it was of course a very anxious time. That was a lot of work. That was 5 years of work to get to that point. And fortunately for us, the launch went essentially flawlessly. They got onto orbit, and after a few anxious moments, everything worked fine.
Well, that is exciting. I know it must have been exciting. That's why I bring it up, because I know that you had all this pre-work done. People should recognize that when scientists take on these roles of these space missions, it's not, it's like a life endeavor, because the mission is from start to finish, the procedures, the protocols, the getting ready, the getting it to fail on land before it fails out in use and service, and that whole process can take up a whole career. And I know that I'm sure that scientists have spent their whole career leading up to a launch, and then there was a launch, and much of the rest of their career, unfortunately, wasn't able to enjoy the launch, the actual mission. But in your case, you've seen full cycle, because now at 10 years, let me ask this question: is there a forecast of where we can go with it? Now, actually, before you answer that, when the spacecraft was launched, it had an initial orbit around Earth, correct?
Yes, and it's still in orbit around Earth. Yes.
Correct. And the orbit, for folks who are listening, they put it into a particular orbit so that during a particular spot in its orbit, it reaches far enough away from Earth, because it's orbiting Earth. It reaches far enough away from Earth in certain parts of its orbits that it's free of any of the interactions of the magnetosphere or the objects, the magnetic fields that are protecting Earth. So in its orbit, very elliptical orbit, it reaches out and it's able to receive its sensors. But one more question about orbit. Through the life of the mission, and I found this interesting, and I saw a video on something else, you changed the orbit because there was an interaction with the moon that may have decreased the life of the orbit?
That's correct. Yeah. After the prime mission, we chose to put it in a very special orbit, so that the apogee, the farthest distance from the Earth, is almost it's 5/6 of the way to the moon. So it gets out there pretty far, and so we put it in a particular what we call a 3-1 resonance orbit with the moon. So when it's as far out as the moon, almost to the moon's orbit, the moon is 120 degrees away and from it, and so that's a very, very stable orbit, because you don't get the perturbations from the lunar gravity.
Right. So the lunar gravity does actually perturb the orbit of a mission like IBEX when the circumstances are there for a perturbation to occur. Okay, let's move a little farther out now then, because we now have an IBEX space mission. Its goal is to track what is known as ENAs, and if I say this right, it's an energetic neutral atom.
That's correct.
And an energetic neutral atom may have started its life off as an energetic atom, or do they all start off as an energetic atom?
So most of the signal that we see, these energetic neutral atoms, start out as from the sun as an ion, a proton, ion off in the solar wind. So the sun produces a wind of charged particles, ions and electrons, which we call a plasma, that is continuous and propagating away from the sun, away from the sun. Right. And so that's most of the atoms we see are from the solar wind. IBEX-lo, the low instrument, can also detect energetic neutral atoms that are from extra solar system, so from outside the solar system. That's a special thing. But what we call the ENAs, they are originally start out from the sun as the solar wind.
Okay. And then how we end up with an ENA is that solar wind is moving outward toward the heliosphere's edge, heliopause, heliosheath, heliosphere's edge, and somewhere in its pathway, it meets an opposing particle.
Yes,
atom.
interstellar neutral. So,
and that one is that one is a grabber per se. What it means is when there's that interaction, that particle that's leaving with the energy gets stripped of it and becomes a neutral atom. And once it becomes a neutral atom, it reverses direction. So if it's heading out and it gets the exchange, it could head straight back. And at that point, it's not affected by magnetic fields. Yes?
That's correct. And so it can cross all the boundaries, the heliopause, the what we call the termination shock, and propagate all the way back into Earth orbit, where we detect it with our very special ENA cameras.
And the ENA cameras, they work 24/7. And the supply of ENAs to the cameras, I've read, is somewhere in the maybe 600 or so per day. So for the folks who are listening, you can think of the IBEX-lo sensor, if I get it right, I could be wrong, about 600 interactions with these ENAs coming back from the outside of to the farther reaches of our heliosphere back in toward Earth, because that therein is the orbit of the IBEX-lo sensor. The sensor, or the IBEX spacecraft, then has, I've read and I found this also very interesting, a very low speed connection to Earth to relate all that data back. Now, that doesn't really need a fast connection with Earth, because the reception of the particles come at such a rate that they can just say, okay, here's one, and then they send the data, and they send the data. And then, as you can only imagine, as this data comes in, it creates a picture which scientists like Stephen are able to look at, and we've had these come out, and then negotiate and analyze and be able to tell where the ENAs are coming from. So, not long after the IBEX mission was launched, and I'm not exactly sure how long, it had enough time in space, in orbit, to make a map of our heliosphere in conjunction with the data that the Voyager 1 spacecraft had and the Voyager 2 spacecraft had at that time, as they were moving out of our heliopause into the heliosheath, and it created a map. Correct, Stephen?
Yeah, so it takes 6 months to make one map, because we look out, the spacecraft spin axis points towards the sun, and we reorient the spin axis once a week. And so if you think about it, if you have the axis pointed towards the sun, and the sensors, because the sensors can't look in the direction of the sun, they look perpendicular to it, they sweep out in the sky a circle in the sky. And then if you imagine reorienting that circle over a 6-month period, you look at the whole sky. And so we knew that after 6 months, we were going to get our first picture, and that's what we targeted to say. We were going to write our scientific papers and get out the results after that first 6 months.
And boy, the IBEX didn't disappoint, because if there's anything about science and all the work that goes into it, you surely do want to have an exciting and an exciting result. Correct?
Yeah, it was truly exciting, because when we wrote the proposal, we had an idea of what we would observe, but of course you're looking at a brand new phenomenon with brand new instruments, and there's always going to be a surprise, and it did not fail to live up to that. It was very exciting to see a completely unanticipated feature in the sky that we puzzled over and are still continuing to puzzle over to this day.
And that's why when I spoke a little while ago, it's the bridge of your work is a bridge from some previous work, which we hopefully will get into this future work, because this future work is going to be quite revealing, I believe, because of the information and the data that's been returned from missions like IBEX. But IBEX was so, as our listeners may be asking, well, what are they talking about? Well, for listeners who are listening, what the IBEX did after 6 months, after receiving all those particles back onto its sensor over 600 a day, it was able to map out an image or representation of what it looks like around the edge of our heliosphere. That is the space where our sun's weather reaches and begins to interact with this interstellar medium. What it showed was that there was a distinct area, and I'll call it now, and it was called a ribbon. So if you think of a globe, and if you just write a squiggly across it from the north to the south, or from the east to the west, or northeast to southeast, and you say, well, there's a ribbon that kind of represented that. And well, how did they know it was ribbon? By color, they could detail the intensity or the amount of particles that they were receiving from the same location. So it was a layered effect. So their first pass, it was all kind of blue. And then as the second pass come through, it started getting more energetic through this ribbon area. And what it showed was that there is a specific area around our heliosphere which apparently shows that there's more energetic activity going on, which in the end is quite interesting, because it's still unexplainable as to why that particular area is a little bit more energetic than other areas. And it's energetic because of the reception of all the ENAs from those particular parts of space coming in from our heliosphere and our reaches outward. Is that a good representation?
That's a very good representation. So you think of a continuous ribbon in the sky, and what we now know about it, the two I think most interesting facts about it is number one, its energy peaks at the solar wind energy. So that was a very important fact about that we discovered. And the other is that, and this was most surprising, the other is that if you take a direction perpendicular to the ribbon in the sky, that and basically follow it out to infinity, if you'd like, that direction perpendicular to the ribbon is the direction of the undisturbed interstellar magnetic field. So this ribbon is mapping out basically the direction of the interstellar magnetic field.
Then this is extreme. Yeah.
We had really not a really good idea of what that direction was until IBEX was launched, and so that was the real surprise. Was that by sitting inside of the Earth's inside of the heliosphere at Earth orbit, we could tell something about this magnetic field so far away from the Earth. More than 150 times the distance between the Earth and the Sun. That far away that we could actually tell something about that magnetic field. And say that, when we wrote, I went back and looked at it, when we wrote the proposal to NASA to say that we would like to do this IBEX mission, we talked briefly about saying, could we say something about that magnetic field? And our team just said that's crazy. If we put that in the proposal, they'll laugh at us. And so we avoided putting that in the proposal. When it turns out that it is at the 1 kilovolt energy, at the solar wind energy, it is the dominant feature in the sky.
Okay, so if I can understand this, because this is quite important, and like as Stephen said, this was another big, if you want to call it big surprise, a big surprise. As our heliosphere is active and in its place in the galactic arm of the Milky Way, we find that it's moving through a stationary galactic magnetic field, rather than the magnetic field, rather than the sun with its heliosphere plowing through the inner space medium's magnetic field like a boat, breaking away at its bow. What we're finding is that the heliosphere is actually interacting and moving through the stationary magnetic field of the galactic inner space medium.
Yeah, it of course, kind of, if you think about it, it sort of pushes that magnetic field away and deforms its direction. And that was, of course, the big surprise is that we now, one of the leading theories of the ribbon is that we are seeing neutrals that have gone so far away from the heliosphere that they were interacting with when they charge exchange, when they became an ion, they were interacting with a magnetic field that had not yet reached the disturbance that the heliosphere was doing. That's very far away. That's probably 200 times the distance between the Earth and the Sun. Right. So that was an extremely surprising result.
And for everyone who's listening, one thing important about space, and I have to interject it: scale is everything. If you want to understand space and the things that are going around outside our atmosphere, even inside our atmosphere, the sheer scale of what we're talking about is sometimes we're incapable of actually understanding it, because the scale is at such a grand stage. And you'll have people who agree or disagree to certain theories come and say that the theory isn't correct, only because they're unable to picture the scale of it. And in this case, the scale of our heliosphere interacting with the inner space medium and the results of the ENA interactions here back at the IBEX and there back out at the Heliosphere is still much work is needed. How long is IBEX ready to go roll? Another 5 years? Another 6 years?
So we, because we put it in a very stable orbit, we also put it in an orbit that is outside of the Earth's radiation belts. So we have a very stable orbit. We have a very benign radiation environment, and we do utilize a little bit of fuel every week, but it's essentially a very small puff of fuel. So ultimately, the limiting factor is going to be fuel, but that's not very limiting. We can say safely that we could operate for another 20 years.
That's wonderful. Stephen, I'm going to put you on pause. I know that we're going to be coming up on a station break. Hold on with me just 1 second, please.
Sure.
Everyone who's listening, this is Collision Course, Saturday nights, 6 to 8 p.m. Eastern Time on Revolution Radio at freedomslips.com, Studio B. Tonight's guest is Dr. Stephen Fuselier with the Southwest Research Institute. We've been talking about the IBEX mission. We'll see you on the other side of the break.
Sorry, are we off? Hello?
Stephen? I'm sorry, everyone. If you can hear me right now, this is Francis with Collision Course. I, of course, just disconnected the show. And Stephen, Hopefully I can get them back. Please bear with me. Hello, Stephen?
Yes, are we still here?
Oh, yes, I'm so sorry. I want to be sure, at 5:31 p.m. our time, can we go a little bit longer? Are you
absolutely. Sure.
Okay, that's wonderful. I'm sorry that it seems like I'm not doing it intentionally. I'm going to try to move a little bit quicker because I got through a lot of the interesting stuff. Well, the most part that's, with IBEX, and we're going to go a little bit farther.
Okay, sure.
5, 4, 3, 2, 1. Hey, everybody, it is Francis with my guest, Dr. Stephen Fuselier, and this is Collision Course. I want to thank you for listening tonight. A very, very interesting discussion about energetic neutral atoms. Those are ENAs in the IBEX space mission. This month, the 19th of October, IBEX will be in action, in service for 10 years. Dr. Fuselier has been a part of the mission since the beginning. In fact, since even before the mission was launched in 2008. Stephen, I really thank you for talking to me. You've been with us now for half an hour, and I'm going to go a little bit deeper into energetic neutral atoms because IBEX isn't the only space mission looking at ENAs, is it?
That's correct. It's not. It's one of several.
Okay. So because we have other missions looking at the same types of things, you're able to combine data that's been outputted from different missions, and then you can get it's like taking a 2D image and turning it into a 3D image because the more data equals more answers.
That's correct. We have a very unique opportunity, which when we wrote the IBEX proposal, we pointed this out, is that we have two spacecraft at the edge of our heliosphere, one who's appeared to have gone beyond it, Voyager 1, and Voyager 2 we are anticipating may also leave the heliosphere in the next couple of years. We have a spacecraft that is on its way. It's been to Pluto, and it's on its way out of the heliosphere as well. It's going to take a little bit longer, but it's at a very important point in the sky, about 40 astronomical units, so 40 times the distance between the Earth and the Sun. And also in the direction upwind, if you'd like, and sort of splitting the difference between Voyager 1 and Voyager 2. And that's the New Horizons spacecraft that visited Pluto and is going to soon visit another Kuiper Belt object. So that's and we had another mission, Cassini, that also had an energetic neutral atom imager on it, and it was in orbit around Saturn. So
I was just going to bring up Cassini because I was going to say we don't always have to go to the edge of the heliosphere to do work about or research about ENAs, do we? And
no, we don't.
What I'm leading toward is the work that, well, not the work, the interactions that an energetic neutral atom has around the magnetic fields of one of our planets inside our solar system. Our sun, as Dr. Fuselier was talking about, I guess gives birth to ENAs in that it's giving off its space weather, or the sun's space weather, with all the energetic particles it's streaming away to the edge of the heliosphere. Well, not every one of those particles reaches the heliosphere. You know, it'll only get to the moon, or it may only get to the outer reaches of Earth's magnetosphere, or in Cassini's case, its research and its observations of ENAs interacting with Saturn's magnetic fields. And I believe that I saw and read a wonderful article about Cassini's work in looking at the aurora borealis of Saturn. I believe there's a lot of work about that. But you say, okay, well, what about Earth now? What were you saying about ENAs and Earth? Well, yes, we have energetic neutral atoms streaming out, starting as energetic ones out from the sun, out to the edge and back again, so the IBEX can read the results. But I've read that the sun's weather interacting with the front of our magnetic field, there's the space in there that creates energetic neutral atoms naturally, does it not?
Yes, it does. And in fact, we see them on IBEX because they're so close, because we're so close to the Earth on IBEX. They are the brightest thing in the sky, and we have set up the orbit of IBEX to try to avoid them most of the time, because we would like to look out to the edge of the heliosphere. But serendipitously, we get to image the Earth's magnetosphere in ENAs as well. And that's been a very interesting process of, just like an IBEX looking out at the edge of the heliosphere, we can look at global interactions.
When you said brightest thing in this bright, I was at a loss for imagining what you meant by that. When you say the brightest things, and I'm talking about the grouping of the ENAs right at the front of the mag, are they illuminate? Are they just to the sensor, to the IBEX-lo sensor? They're very bright. To the
IBEX-lo and the IBEX-high sensor. What happens is the solar wind, which is charged particles, comes in, approaches the Earth. It gets deflected around the Earth's magnetic field. But in the process, if you think about it sort of right along the Earth-Sun line, those particles essentially go right up to what we call the magnetopause, and then have to flow around the Earth's magnetic field. Well, a small fraction of them charge exchange with the neutrals, very cold, low energy neutrals that are in near the Earth. We call it the geocorona. They're hydrogen atoms that are near the Earth, and so that produces an energetic neutral atom. And if you look off to the side, as IBEX often does, you see a very bright emission in ENAs from this subsolar point.
And for everyone who's listening, a lot of you and myself, we've seen the representation in one way or another of how that space weather comes out, because there's we have readers and test meters, and there's folks out there who always have their eye, the NASA one. I'm not quite sure what it is, but it represents the sun and the swirling of the magnetic fields, and so that when the sun has a coronal mass ejection or a solar flare, that graph tracks that interaction off the surface of the sun all the way to Earth through that process. But what happens is on a extremely weather-rich day, which means the Earth is being impacted by a lot of space weather, it actually pushes up against the front of our magnetic field. And so, Stephen, I'm here at this point right here, and I want to ask a question, and I don't know what the answer is, of course. When that pressure builds up to enough, the magnetic field breaks?
That's correct. Well, it actually kind of breaks all of the time, but when the pressure is high, that magnetic field breaking, if you'd like, we call it erosion. It actually erodes away the front side magnetic field lines of the Earth, and so it brings the solar wind, the shock solar wind, a little bit closer to the Earth, than normal, it can actually get within geosynchronous orbit, where it affects the radiation belts dramatically. That breaking is actually a region of my an aspect of my other research, which I study on MMS, and that is magnetic reconnection.
Then here we go. I'm sorry, but I really did have a good time this week reading up. So I want everyone to put in their mind a picture of that representation of the space weather hitting Earth, and we all know that it's protected by its magnetic fields, and hopefully everyone is able to create this picture in their mind. So we have the Earth in the center of a couple of bands of what we'll call our magnetic field. There's one leading band, and then there's one in between Earth and that leading band. And when that space weather comes, it starts pushing on those two bands closer and closer to Earth. And if it's too energetic, the first band may break. And then that next band will be there responsible for taking up the pressure. So what the IBEX and the ENA and I guess the MMS missions have shown us is a little different way to look at that interaction and what is really going on. Because if we only want to look at it as the space weather hitting those magnetic fields and then flowing to the top and to the bottom and then just heading off into this perfect tail, it's not what's actually happening. Because along with the energetic particles, we do have a thing called plasma, which Dr. Stephen is very done much research and work with, and I hit my microphone, I'm sorry. I'm very animated about this topic, is that those plasmas and the particles and then the interaction with the magnetic field, and then we have this very brightening of the ENAs. It's very, very dynamic. And then if it's so strong, you have the magnetic field breaking away and this degradation and to the next. And why am I bringing this up? For, of course, the biggest reason, we have to have a protected Earth. If anyone had a question, why is this discussion happening? What is this discussion about? We have to understand these dynamics so that we can understand what kind of pressure our environment is really under. At the heliosphere's edge, even when there's extra pressure from the outside, it can make our heliosphere smaller, allowing more particles in toward Earth, which actually will do us harm in the future, right down to our DNA, because these ENAs that we're talking about, there's nothing stopping them. There's no magnetic fields driving them away. Once they're created, they're ripping away at the opposite direction from start to finish with nothing stopping them. So these interactions, so my question, as I'm getting there, have you or what is your opinion about these areas with that image of the space weather going over to the top, but actually that not being true because there's a little coma now, a coma underneath the Earth that is a collection, if I can remember right, a collection of plasmas that may assist in I don't want to call it reconnection because I read you can't reconnect, in a rebuilding or resurgence of magnetic fields to replace or repair the broken one in the front. Did I get through that at all? Worth anything?
Reasonably well, yes. We understand quite a lot about reconnection, having flown now the MMS mission, and
so a field can come back together again after it's been broken.
Yes, and what we get is the field will go into the tail, actually reconnect again, and then convect around to the day side and sort of replenish the magnetic field. So it's a circulation pattern in the magnetosphere that essentially keeps the dayside magnetic field lines present. So you can't just simply erode away the magnetic field and nothing happens, because that drives a reconnection process in the tail that replenishes that plasma from the night side to the day side.
Well, this is all very. It's an important topic for anyone who's listening and trying to follow along. Again, I'm gonna do follow up on this because it is important. It's important for us to understand this because the science that's going on in these areas are going to be the stepping stones onto which our future science books will be written about. And as we get into the future of science books and science books in the future, they're going to incorporate more of these interactions that we may have never seen before. Even though we've been seeing them for 10 years, it still takes the determination of a scientist and groups of scientists, because as I learned when I was researching, Dr. Stephen Fuselier is not the only person out there, and Dr. Dave McComas, he's got lots of friends, lots and lots of friends who've created many, many papers about this topic because it's important to them and our understanding about what we're going to understand in the future about the interactions of ENAs with Earth, ENAs at the edge of the heliosphere. What is the edge of the heliosphere actually? What does it mean to us here on our planet? And at the same time, what does it mean to our star? Because we may not have talked about our star, but our star needs to be, if at all possible, understood so that we can maintain our knowledge about it and be aware of its future activity and how it affects us. David, I'm going to throw out a real oddball question. Forgive me, because you may have no idea. And it's about. Did you hear the story about the new the new planetesimal they're calling the Goblin?
Oh, I heard something about this where they think they've discovered a moon orbiting another planet, orbiting another star.
Well, no, this one, recent research about Planet 9, Caltech, the gentleman from Caltech, Boytkin, and the other gentleman, they're using planetesimals in far out reaches with orbits that are incredible. I mean, when I talk about scale, some of the orbits of these objects like Sedna, and of course I just want to get this question out to you. Sedna, and so the farthest reaches things, but out of all the objects, they never gave us an object with the extreme orbit, which tells me that this object leaves the heliosphere. 10,000-year orbit. It's out there at 2100 AU at its farthest point. In your mind, is that possible?
It is possible because we have comets in the what we call the Oort cloud, which extends.
And that's past the okay.
Yeah, that's well past the heliopause, which we identify at between 100 and 150 AU, and so it's certainly 100,000 AU is certainly possible. To be still.
Okay, I was just that was some news that came up this week, and I really couldn't do the math correctly, but I needed somebody, and I know you weren't the perfect person to ask. I could have. The next week's going to be the perfect person, but I just had this question. I just had that, so I appreciate you with that.
We have to be careful when we talk about IBEX studies that we're looking at what we call the edge of the heliosphere. And the heliosphere we define as the interaction between the sun and the intergalactic or interstellar medium. So where that interaction ends, if you'd like. The edge of the solar system, that's out past beyond the Oort cloud, and which is a lot further away. So we always have to be careful to make that distinction when we talk about the IBEX observations or Voyager. That Voyager hasn't left the solar system in an astronomer definition, but it has left the heliosphere.
Well, that's very good. That just leaves me a little bit something more to research, which I don't mind at all. It's if I have to go out there and find out for myself, I ask the questions. Okay, we're coming. I'm gonna let you go in the hour. I know I kept you for an extra half an hour. I do want to talk about two things that we talked about before the show as we were doing our sound check. You have had the great pleasure in your early time working as a grad student teacher to work for Dr. Van Allen. And for the guests who are listening, Dr. Van Allen is the scientist who is noted and has them named after him, the Van Allen belts, which are the radiation belts that are around Earth. And there's much discussion about Van Allen belts, and I don't want to get into Van Allen belts too much with Dr. Stephen. We can do that at a later time when we can have another guest and talk about those more specifically. But I wanted everyone to know that Dr. Fuselier worked with Dr. Allen, and what a rich history and knowledge he has, because I did a little extra research, and Dr. Van Allen was responsible for scientific instruments on the second Admiral Byrd expedition. And I brought this up with David, and it's a little less dramatic the second time, but did you and Dr. Van Allen have any talks about maybe Dr. Van Allen's history and what really, out of your interpretations, what really meant the most to him, or what really sank with him in his time?
It was, of course, really enjoyable to be his teacher's assistant. And then I became a student of one of his students, so sort of second generation, if you'd like. And he was, of course, extremely proud for having the first U.S. satellite in orbit, Explorer 1, and then following that up shortly, Explorer 3. Explorer 2 ended up in the ocean, but that's another story. But he was extremely proud of that accomplishment, and extremely proud of the research that they did using a very simple instrument on Explorers 1 and 3 to gain such rich knowledge of near Earth space that was sort of anticipated but never really appreciated until we got out there. So I think that that was his great pride. But he also took great pride in teaching. He ran a general astronomy class for many years, and he always considered himself a teacher first, and that was really impressive to me. Just his dedication to teaching and to his students.
Well, I want to tell the listeners that Dr. Stephen Fuselier is the same as Dr. Van Allen. I really feel that through all your interactions that you've resulted in exactly what you admire in other people like Dr. Van Allen. I know that you're responsible for training and teaching other graduate students. I am blessed, or my family is blessed. We have our one son. He's a sophomore this year. And he's scientific computing, and he's going to be in the field. We don't know quite yet where or how, but our boy is going to be someone who is going to hopefully lead us into the future of science. And I couldn't be more happier trying to relate what's going on in science right now than I motivate my son to learn about what science is going to be in the future, all the while instilling in him the pleasure of learning. And if people don't find learning to be pleasurable, they may not be learning what they should be. So
yeah, and I really second that. And I should say too that we talked about all the research that I've done, but that is certainly not done in a vacuum. One of the great pleasures of working on IBEX for these 10 years has been working with the IBEX team, which has been dedicated, extremely intelligent, extraordinarily productive, and very cohesive. we argue and debate about things such as the origin of the ribbon, but it's a scientific debate, and it's just an extremely pleasurable to be able to work to be able to get up every day and go to work and interact with these other scientists that are just extraordinary. They and then to have the chance of sort of passing this excitement on to my students, that's been a lot of fun.
Okay, we have a break. Hold on 1 second with me, Stephen.
Okay.
Radio at freedomslips.com, and we'll be right back after this message.
Narco-syndicalist commune. We take it in turns to act as a sort of executive officer for the week. Yes. But all the decisions of that officer have to be ratified at a special bi-weekly meeting. Yes, I see. By a civil majority in the case of purely internal affairs. Be quiet. But by a 2/3 majority in the case of more... Be quiet. I order you to be quiet. Look, you stupid bastard, you've got no arms left. Yes, I have. Look! It's just a flesh wound.
I don't believe I've seen such a display of courage, skill, nerve, grace, and stupidity.
I'll do you for that. Oh, what? Come here. What are you going to do, bleed on me? I'm invincible. You're a loony. The Black Knight always triumphs.
Roundtable Live, Monday through Friday, 1 a.m. till 4 a.m. Eastern Time. Bring your mind, bring your ideas, bring your voice. King Arthur had nothing on us here at Revolution Radio, freedomslips.com.
Enjoy your extra big-ass fries.
You didn't give me no fries. I got an empty box.
Would you like another extra big-ass fries?
I said I didn't get any.
Thank you. Your account has been charged. Your balance is 0. Please come back when you can afford to make a purchase.
No.
I'm sorry you're having
trouble.
trouble.
Come on. My kids are starving.
Thank you for tuning in to Revolution Radio. Here at Revolution Radio, we believe in freedom of ideas, freedom of speech, but above all, we believe in freedom of existence through self-reliance. This station is 100% listener supported, and as a fundraising promotion, I have a kick-ass free gift for a $100 donation. 35,000 seeds. 25 years in the freezer. Long-term storable, 54 different varieties. So if food prices go crazy, the shit hits the fan, or if you just want to save tons of money every year by creating your own food like I do, grab our seed pack special. Just look for the banner on the homepage at freedomslips.com. Don't be a statistic. Don't be part of the problem. Be part of the solution. We need, as humans, to start taking care of ourselves and not depending on the megacorps to provide unhealthy, nasty food. Included in this package is also a DVD with 900 survival and off-grid living documents and the offline home canning how to do everything website all on the DVD. So when you're growing all that food, you know how to can it, store it, preserve it, etc. with all these documents. So thank you for tuning in to Revolution Radio at freedomslips.com. I hope that you will pick up this package and start learning to be free. Revolution Radio, freedomslips.com, where information never sleeps and freedom is one seed that needs to be planted.
What we do in life, it goes in eternity.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free, but there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver Eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no us. Revolution Radio, where information never sleeps.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Good evening, everyone. It's Francis, and this is Collision Course. This is the second part of a 2-hour show. Stephen, are you still there with me?
I am still here.
Okay, I'm. Thank you so much for waiting through that. I didn't want to just cut the call off because I want to say thank you so much for joining me tonight on this show to talk about IBEX, to talk about the research that you do, the science that you know about, because I think it's very, very interesting. I know that my listeners find it interesting, and the more people like yourself that I can contact and speak to, the more information that the general public has. And in that is my motivation. And I've always had a great respect for the scientific community because you know what? They're all just like you. And I know that you took the extra step and you contacted David, and David came back to say, yeah, it was okay. I want to thank you for that. I know that if there's anything in this world right now, there's not enough thank yous going on. So Dr. Stephen Fuselier from the Southwest Research Institute, he works with IBEX, he works with MMS, he works with the energetic neutral atoms. When I come up with another great discussion to have with you, Stephen, I'm going to send you an email, and hopefully you'll take my call again. Is there anything that you would like from me, or anything that I didn't cover that you think I just forgot because I don't know?
No, I think that was really good. I really enjoyed it, and I was lucky. I happy that I got in at the end. That my research is not done in a vacuum. I really, really appreciate all the work I get to do with all the collaboration I get to do with scientists around the world, and it's just a very enjoyable career, and I enjoy passing that on to my graduate students.
And I thank you so much. And like I said, when we get, maybe we'll get, we don't even know, we'll be getting information for IBEX for as long as we can handle it. If we find something new, I will get in touch with you. And so, Dr. Stephen Fuselier, thank you for coming on Collision Course. I'm going to allow you to hit that red button and let me go. Thank you, thank you, thank you. I hope to speak to you again soon.
Okay, goodbye.
Goodbye. 5, 4, 3, 2, 1. Hey, everyone. It's Francis, Collision Course. Dr. Stephen Fuselier just, we just tidied up on that conversation. So much to talk about. I really put it in that first hour, but I know that I'm going to have some more discussions about it because I want to stretch it out. I want to break it down. I want everyone to know it's so important to be hearing the information from the folks who are doing the research. I find it quite tiring sometimes to have to work my way through theories and theorem from folks who may not have done as much work as they need to do to get an actual answer about what they're talking about. When we talk about energetic neutral atoms and we talk about someone like Dr. Stephen Fuselier, we know we can't go anywhere else but there to get the answers about what's going on. So somebody might say, okay, Francis, you forgot a question. You might have forgot some more questions. That's okay. If you heard me right, I can get them back. We can talk about it later, create some questions like we should be doing so that we can introduce those to him at a later date and get some answers. We're not left with, did you get them tonight or you'll never get them again. I want to make sure that my guests come back, have a place to come back and relate back to you the information that they're learning about the space outside our atmosphere, about energetic neutral atoms, about how they're hitting Earth, how they're hitting the IBEX space mission, how they hit the Cassini space mission, how they're hitting Saturn, how they're hitting the Heliosphere, heliopause, all of that. Because if you take time to do some research about what we were talking about tonight, you'll find out that it's ripe for new revelations and new discoveries. Once all the pieces get put together, they'll have to come up with an understanding of how this energy, magnetic, energetic, neutral, or otherwise, is going to interact with how we understand the properties of physics and solar dynamics, planetary dynamics, and such. When we talk about these events of space weather being charged particles and hitting the magnetosphere of Earth and creating, as the doctor said, a very bright area of energetically neutral atoms, those energetically neutral atoms have no boundary kept by magnetism, and it's very relevant in the fact that those are the types of particles and the like that are going to do us harm if they get into such a viscosity. I use the word viscosity because I can't think of anything else. If they get into such a viscosity, a thick viscosity, these energetic neutral atoms or energetic particles, they can disrupt life on Earth. And that's part of the reason why we're talking about it, why it's important to know about this science, because it is about protecting Earth. It is about protecting us. As you know, tonight's the premiere episode of Season 2 of Collision Course here on Revolution Radio, freedomsips.com. freedomsips.com and Revolution Radio is a listener-supported radio station. That means if you support free speech, you should support a place like Revolution Radio on freedomsips.com. There's quite a number of places for you to take advantage of your right to help free speech along. This station allows not only me, but over 30 other hosts to get their information out to listeners like yourself. It doesn't happen without some help. It doesn't happen without a dream. It doesn't happen without the hands moving the machine to allow us to get on air for you to hear. I say that because Revolution Radio has always been a great, I call it an escape for me, because a place to give your information to the public should be a cherished thing. To have a platform to speak about what it is you love is a cherished thing. To have a platform to inform others of things they may not otherwise get a chance to interact with is a treasured thing. I said somewhere in one of my promos that there's something important that I'll have to relate to you all in regards to my understanding and belief systems regarding outer space. You see, I must have an understanding and a belief pattern about outer space in order for me to speak about it in a determined manner. And of course, I always like to speak about things in a determined manner. And when you're determined and in a determined manner, that means you'll stand up on what you say. And if you stand up on what you say, you might as well get ready to do some research. And if you don't know me, we are ready to do the research. We've already begun taking pictures of outer space in the area around M23. We're looking for Planet X. We're looking for transient objects. That's what I'm most fanatical about. I'm the biggest fan. An asteroid, comet. Now we're talking about these far-flung planetesimals that science is interpreting as a pathway to the recognition and realization of a ninth planet far-flung. In the process, they've discovered something recently this past week they called the Goblin. I found it interesting because they released it as new information, yet the Goblin has a number of 2015, and I don't know, P387. I could be wrong. I'm most interested in the date 2015, because when they come out and Phil Plait from Bad Astronomy, and I don't like Phil Plait, and I don't rely on him, and I don't like him. When they want to bring new information about this new discovery, yet they give us a date of 2015, we must know that object was discovered in 2015. What it's doing now is it's just tying into the research that they're doing about these far-flung planetesimals. These are objects that have orbits that are extremely large. They may not even come in as close to the sun as Neptune. And in fact, the Goblin, the one that they discovered, or the one that they're giving new information about just recently, and I talked to Dr. Stephen about it, they have it on an orbit 2100 AU out. That's a 10,000-year orbit. That's 2100 AU out. And I must do some more research on what we're talking about today, because as we learn about our spacecrafts exiting these areas and on their way outside our heliosphere, I maybe never thought about that being an object going out that far. But Dr. Stephen Fuselier talked to us about the distances. So one of these shows coming up, we'll talk about distances. Actually, I have just the show for it. Next week, we have one of the scientists, a TED speaker, who's going to be talking about Oumuamua. That is October 13, Dr. Karen Meach. And Oumuamua, that is the interstellar traveler that came in from way out outside our solar system, came in and is going to leave on a hyperbolic orbit, which means it'll never come back. That's that object that was discovered after it had passed the sun, and it was that long cigar-shaped piece of rock. And if you go to my Facebook, you'll find me on Facebook. If anybody's on Facebook and they want to find me, go on there and search for Francis Walsh. It should be pretty easy to find me. Or search for Collision Course. Should be pretty easy to find me. I'm always making posts over on Facebook. There's a lot of information there. But in the information that I share, we're gonna set up topics that we'll talk about in the future. Okay. This is, as I was saying just a moment ago, in order to have a leg to stand on, you have to have an understanding of what it is you're standing on. In my hands are one of two papers I found very interesting. This one comes from Harvard. Let me see if I wish I could give it credit. Astronomy. Okay, we're going to call it Chris Empey. This is the actual. What's the actual paper? Let's get to it. The End: Astronomy meets Eschatology. Chris Empey. Stewart Observatory, 933 North Cherry Avenue, University of Arizona, Tucson, Arizona, 85721 USA. The End: Astronomy meets Eschatology. And yeah, I'm going to work my way through this article, and when I find a spot that I feel like I should explain my point of view, or what my beliefs are according to what this article is going to tell us, and it's not an article, it's a paper We'll just go from there. Earth from its orbit of the sun, sending us into the deep freeze of interstellar space and extinguishing all life except that near deep sea vents. Again, it says plate 2008. I find Phil Plate to be with too many words. Enough said. Do I have this numbered right? Make sure I have this numbered right. Stellar mayhem. Without the sun's rays, the thermal blanket of the atmosphere would only sustain the Earth for a few days before our planet's thermal energy leaked out into space. So, let's get that right out. Without the sun's rays, the thermal blanket of the atmosphere would only sustain the Earth for a few days before our planet's thermal energy leached out into space. Not magnetism, not gravity, the sun's rays. Okay. Luckily, the sun is a constant companion, varying in its output by less than 0.1% from one year to the next. Even so, sun-triggered climate change has caused regional famine through history. However, its effects are unlikely to end the species our ancestors preserved through deep ice ages with few creature comforts. Here's another point about what we'll read. You may read something that just doesn't sound right. Well, that's in the paper, so we're going to have to understand the paper as far as it's written and try to think about why it's written. Most stars are less massive and much longer lived than our sun, but the increased time scale of supporting life is countered by a slender, habitable zone. It is a curious coincidence that the time taken for us to evolve from primitive forms of life is within a factor of 2 to the total lifetime of the sun. If it is generally true that intelligent life takes several billion years to evolve, then stars much more massive than the sun will be lonely places, since they will die while life is still simple. If it had taken twice as long to go from simple cells to humans, we would be facing the uncomfortable prospect of the loss of our only means of support. So what they're saying is that some of the supermassive stars that we'll see in our night skies will never, ever have an opportunity to give birth to life, only because its life itself will not be around long enough to sustain life somewhere else. We must be appreciative of our system, which allows us to have the environment to which our life could have been evolved, if that's what we were to believe. The sun avoids the spectacular fate of more massive stars, though, where the final exhaustion of nuclear fuel triggers a titanic explosion called a supernova. For a few days, the dying star brightens to the rival of light of a galaxy. It also emits high-energy particles that can destroy the ozone layer of a planet like Earth. And this is important. When we have these grand explosions of supernovas, they are sending those particles outward in all directions. If you're a place like Earth and you're in its neighborhood, you are going to have to go through those particles at one point. It is those type of particles at the same time that create the energetically neutral particles, because they are the gas to the flame of the sun's particles leaving the face of the sun. It also emits high energy particles that can destroy the ozone layer of the planet of the Earth if it occurs too close. Luckily, massive stars are rare and their violent deaths are very infrequent. There hasn't been one visible in our daytime sky since the time of Kepler. Remember, look at what he said, the daytime sky. Daytime sky. It would have to be pretty bright to be seen in the daytime sky, and if it happens in the daytime sky, It's a big thing. A supernova must explode within 30 light years of Earth to cause direct damage to the biosphere. That's 30 years, then, according to this paper. A supernova 30 light years from Earth to cause direct damage to the biosphere. We'll have to look at how far Betelgeuse actually is. No such star or its remnant is seen now, and on average, this type of event is even less frequent than a giant impact. Supernova explosions may have caused the death of the mammoths and other large North American mammals, and then again, it may not have. Again, I'm reading the paper, doesn't mean I have. I'm reading it to say I'm supporting that view. Mammoth tusks from that time are peppered with iron grains that impacted at 2 million miles per hour. And there are sediments rich in radioactive isotopes and extraterrestrial origin as well. Well, now we're getting close to evidence. Stars move through space, and 3 million years ago, we were much closer to the Scorpius-Centaurus association of young stars. There's evidence for an excess of radioactive iron in the association of young stars. There is an association of radioactive iron in the Earth's crust at that age consistent with a mini extinction of sea creatures like mollusks. As even more dramatic event is called a hypernova, where the violent collapse of a very massive star ejects jets of gas and high-energy particles at close to speed of light. For a few moments, the star outshines the rest of the universe in gamma rays, and any hypernova pointed at us with 1,000 light years would cause an upward pulse in the mutation rate of life and the destruction of the ozone layer. And see, this is why missions like IBEX is so important. Missions like IBEX, they have a general mission and protocols to achieve the mission goals, but these space craft ships are also there as our watchdogs for these extremely exotic events. Now, you may say, well, that isn't going to do us much good because the particles will hit Earth and they're going to hit the spacecraft and we won't have any time to know, but we may have time to know. There may be an escalation of events that foretell of what's going to happen in the future. Galaxies seem eternal. Stars like the sun will someday die, but nearby in Orion and Taurus, freshly minted stars are switching on for the first time, and herein is a statement that must be supported one way or the other with some of the information that we talked about tonight. Some of the information we talked about tonight was brought up in order to make a connection to how space weather, energetic neutral atoms, space weather and magnetic fields, the sun's heliopause moving through the inner space medium, how are they behaving, and is our interpretation of their behavior going to remain the same, or is it going to change? You ask, well, why would it change, and what is drawing that conclusion? I am not going to do anything more but continue associating some of this behavior to an electrical response without taking on the hyper theory of the electric universe. We may be able to work out a theorem of combinations of electric theory and gravity, and I've read and I've listened to that when electricity is present, it is the dominant force, and then as it dissipates, you may have your gravity take over. We'll have to do much more research. This is only episode 1 of season 2. We may have to go all the way to the end of the season, but I will be sure to reach out to those folks who are brave enough and with enough knowledge to bring into the circle and add to the basic knowledge that we're building about energetic neutral atoms, about how space weather interacts with Earth. Is it, was it, how's it going to be? Does the observations support this or that? Massive stars will die explosively as supernova, leave behind a neutron star or black hole. Stars like the sun and those less massive than the sun will die as white dwarfs. And again, that's a very broad statement without even detailing the dynamics that it gets you from here to there and why it occurred. But I'm reading this paper because it's telling me what we need to be researching. What is between the lines, unfound and unstated. The most distant endings in astronomy are uncertain because they depend on aspects of nature that are not well measured or well understood. After the initial impulse provided by the Big Bang, and again, new theories, new information, a new understanding may be in our future. The universe expanded at an ever-decreasing rate. Observation of microwaves in the early universe provided evidence that the universe is flat, implying that it will expand forever. This prognosis was altered by the discovery of cosmic accelerations known as dark energy, a manifestation of the vacuum of space with a force opposite to gravity. It causes repulsion rather than attraction. Dark energy was expected, and it remains enigmatic, and it's enigmatic only because it hasn't been proven. I'm getting some contacts in on my Skype. I just want to get through this paper, so please bear with me. Oh, hey everyone, it's Francis Walsh. This is Collision Course. I want to thank you very much for listening. Saturday night, 6 to 8 p.m. Eastern Time. Collision Course on Revolution Radio. Enjoy the break. Hey everyone, it's Francis again. Collision Course on freedomslips.com, Revolution Radio. Yo, Nighthawk. I was sorry about that dead air, everyone. I was trying to wait and make sure that I had it on. I wasn't sure if the break happened because I didn't have any audio into my ear for the break. But really appreciate everybody listening. This is the first episode of Season 2 of Collision Course. Earlier we had Dr. Stephen Fuselier. We talked about the IBEX space mission. We talked about energetic neutral atoms. We talked about where the interactions are happening, occurring, and what his interpretation of those interactions was. What he told us in the end is that all the discoveries were exciting, and there has been 10 years of discoveries. And still after 10 years, there is an understanding that those discoveries still don't give us a full understanding of what's going on. I'm sure that in the near future, even though they don't come out and have the full, complete story answers about it, they're in the background trying to come to an understanding how to bring electricity and gravity together in a way that will satisfy everybody. And once science has enough data to do that, there will be many who will probably become satisfied and recognized as being one who led the fight in the electric universe theory, and why didn't it happen a long time ago. But as science sees it today, it sees the energetic atoms interacting with magnetic fields. They see the heliosphere, the solar system, interacting with the interstellar medium, which contains its own magnetic flows. And in the process of understanding the interactions and dynamics of magnetic fields and space weather, they're going to recognize that electricity and magnetism plays a great role. And the interactions of our solar system objects and the space weather. You're not going to be able to get away with the fact that magnetism and space weather, in it there is an electric component. And though it may not be detailed and defined by science as of today, while it has been understood and defined by researchers of the day, and you can find plenty of information about it, I am still of the mind and heart to wait for science to bring that paper forward, because if there's anything I must stand with are the papers about the science that we're talking about. And we have to afford the scientists time to do science. And sometimes we don't do that. Sometimes we don't allow science time to do science. And they say, well, it's been 500 years and 600 years, and God, I just want my electric theory. I just want my electric universe. I don't care about anything else. I don't care about gravity. I don't care. I just want my electric universe. Give me my electric universe so that I can go to bed and I can stop researching. Well, that is something that we can't do. Whether we have a theory that's going to be recognized and understood, or we have an understanding of something and we're having to do more research. We may want something really, 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 really bad, but we may not. But the only thing we may get out of that want is work to get to the answer, if there is an answer that we can understand about the questions we ask, because the questions we ask are just as important as the research that goes into it. We're talking about this paper from a student from Arizona, but it also has ties to Harvard. And basically, it's astronomy and eschatology. Eschatology, if you didn't know, has everything to do. People want to say it's about end of times, but it's not really about end of times. It's about scenarios that could bring about the end of times. Let's look at eschatology that way. Eschatology could be a guy researching about all the different types of events that could bring about the end of times. Now, there are researchers of eschatology who only research religious type objects or religious scenarios, that i.e. they're reading the Bible and they're trying to prophecy through Bibles and etc. what the future is going to hold. We have geologists who do their prophetic work in a sense that they may be interested in rock formations and historical geological formations in order to detail what the future is going to bring. We have scientists who are out recognizing historical construction of objects and tying those into historical dates and importance according to our knowledge of history. Because again, as we are in our 2018th year, there's still much to learn about our year 5 or our year 6 or our year negative 10,000, because between you, me, and everybody else, even though it may not be out in space, it could be here on Earth, these historical sites prove to be quite exotic and either misunderstood or not quite understood. Back to the cosmic catastrophes on an even larger time scale, longer time scale, structures become unglued. In about 10 to the 15th years, planets will detach from their dead stars and drift through interstellar space. Let's think of that. On even longer time scales, structures become unglued. In about the 10 to the 15th years, planets will detach from their dead stars and drift through interstellar space. In the 10 to the 19th years, stars will begin to detach from galaxies and float off into intergalactic space. Most theories that unify fundamental particles in terms of a single super force predict that the proton is not stable and will decay in 10 to 35 years or so, 10 to the 35th years or so. The decay of protons heralds a final phase of disintegration in the universe as everything falls apart. After the unimaginable time span of 10 to the 66th years, even the most compact objects will disappear as black holes evaporate. The outcome is a victory for the second law of thermodynamics as the universe turns into unstructured matter and radiation. If you haven't followed, what he's talking about is the slow disintegration of the universe due to supermassive year scale of time frames. Because again, if you've been listening to the show, scale, what is the scale that we're looking at? It's the scale of time, the scale of size. It's so easy for someone to forget the scale of something and say, yeah, that theory is right, just because I can't imagine that the Earth is as big as it is and that my puny eyes can't look as far as the edge of the horizon. And I can't imagine that it's rolled over where the sun go. Ask the Egyptians where the sun went. Vacuum energy is the wild card in the foretelling of a universal eschatology since its properties are poorly understood. Here he is. Vacuum energy. A vacuum is poorly understood. It is poorly understood because we're using this complete gravitational understanding as a way to work our processes through vacuum energy. Vacuum energy is the wild card in the foretelling of a universal eschatology since its properties are poorly understood in some opinions or in some options. Still permitted by the observations, dark energy is not the cosmological constant of Einstein's original theory, but varies over time and space. If dark energy grows, it will unbind galaxies, then stars, and then atoms on a faster timescale than that of the metaphysics we just discussed. The ultimate fate of the universe is something called the Big Rip, where the structure of space itself is rent, and space can no longer serve as the backdrop for any kind of cosmic history. Some variants of cosmology propose that our familiar three-dimensional space is embedded in space of higher dimensions, in which case the Big Bang is simply an event among many space-time events and the process can continue without beginning or end. If we can believe this theory, it is the ultimate reassurance. At the very end of the article, it looked for reassurance. Reassurance is a common core through many wishes and dreams of those who are in search of an answer. Astronomy is something that I'm going to focus on because it's something that I'm excited about, and the people that are involved in it excite me. People like Dr. Stephen Fuselier, who we had on this evening, does contain more information than we were able to get out tonight due to the, we only have them for a limited amount of time. We don't want to necessarily overkeep them. We don't want to overstay our welcome. So what we do is we take what they'll give us, offer them an opportunity to come back, create a reason to come back, and then have them back. And that's all we can do. I want you to know that over the next couple of weeks, we have 2 more wonderful guests coming. Next week is Karen Meach. She is a TED Talks presenter and scientist, one of the scientists responsible for the research done on the interstellar traveler known as Oumuamua. If you didn't know who Oumuamua is, it was an asteroid that came flying in at extreme speeds into the inner solar system. It wasn't noticed until it was on its way up, which means these objects will come in toward the sun, and then the sun will be the part of their orbit. They'll wrap around the sun and head back out. The object wasn't noticed. The object known as Oumuamua wasn't noticed until it had passed sun and it was on its way out. Much intrigue and interest has been put on this object because of its origin. I've done a lot of research on it already, and I will tell you now that while this object carried with it a lot of news and media, that if you look at the space in between the sun and, let's say, Mars, these types of objects coming into our inner solar system and leaving on hyperbolic which means an orbit that it won't return on. A hyperbolic orbit is one that doesn't have that egg shape. It just has like a V. It comes in, makes a sharp turn, and it heads out, and it makes like a V, and it'll never be back. These types of objects come in from places outside our solar system, and with the case of Oumuamua, it was coming in at an extremely fast rate, which detailed to the scientists who were following it and the astronomers who were following it that it had been on its way for a long time to accumulate the speed that it has. Now, with it having already gone by, scientists are trying to look at where it came from. That find it very interesting about where it came from, and they're doing that work. They've pointed out a number of areas in the night sky that it came close to, but they have not associated a certain location for where it originated, and they don't have a location where it's going to. But Miss Karen Meach, Dr. Karen Meach, did make a point during her TED presentation at the very, 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 very end. She said, and I may get this quote wrong, I'll get it right, quoted when she gets here. She said something to the effect that, if anything, we were happy to be the first to say hello to an interstellar traveler. And as you hear it come out of her voice, it sounds as strange as it sounds. Because you have to look at the object and know that she's an astronomer and it's an object. I don't know if I've been able to associate an object that I've been looking at or associated to with such a humanistic conversation type reply to. So I'm going to talk to her and see about how connected she actually is to Oumuamua, and if there is some knowledge that she has that really connects her to this, because it's something more than just what it is. And it'll be very interesting to find out about that. And then the following week, the 20th of October, we have Dr. Renu Mohatra. Dr. Renu Mohatra has been working very hard on Planet 9. We know Planet 9. Planet 9 is that planet that we've discussed or is being discussed, but yet to be found. Discussed, but yet to be found. Why are we discussing it if it's yet to be found? Because of a bunch of different objects orbiting the sun way out there. And I talked a little bit about it with Dr. Stephen Fuselier with the Goblin asteroid. You all probably heard about the Goblin. Well, they've added that into the group. Now we have 6 or 7 planetesimals that orbit the sun at great vast spaces and large orbits that appear to have similar orbital paths. And if not anything, that their similarity in angulation and amount of time in orbit and when they're coming and where they're going, they believe that because of all these similarities, it must point to the Planet 9. And if you know anything about searching for new planets, planet perturbation, or the effect that a large object or a large planet has on a smaller object as it passes close by, is called a perturbation. And we've used the word perturbation and the process of perturbation and observing perturbations, and then looking past the perturbations, looking for the perturber. And we've had that in the past to discover our outer planets, and scientists still believe that through these additional information and perturbed planetesimals, we will be able to find Planet 9. I can tell you myself, I am right now observing the star cluster M23, 6494, NGC 6494. Telescopes pointed right at it over a period of time. I'm looking at 6 months of surveying that area. I'll tell you more about that because that has everything to do with the Citizen Space Force, and we're going to unveil the Citizen Space Force and what does that actually mean to Collision Course, what does it mean to myself, and what does it mean to the advancement of citizen astronomy in such a way. So there's a lot of exciting things that are going to be they're going to become a part of Collision Course. Collision Course was born on the idea of good quality conversation about good quality research. Even if the conversation that was had didn't reveal the deepest, darkest secret or the most information that it possibly could have, the creation of the discussion about the topic and about the evidence that the mission produced can be used later to finalize research results. Since the Space Force is going to be a force to reckon with first, while it takes on missions to uncover information about such topics. You'll find out that there are designated mission experts like myself who are going to take on the role of connecting us to the information in the best way possible. Everybody knows one person can only get so much done. We do get a lot done because we work at it, but any help that can be acquired is good help. This article that I read to you may not have been too exciting when you heard it, but in its overall scope, what I wanted to get across is that some of the highest or most respected schools and organizations and academia have put their minds into thinking just the way you have and just the way I have. Not many people would expect to go into Harvard and find a paper that talks about the end in astronomy meets eschatology. Many people don't even know what eschatology is, but it's important in our realm because you know as well as I know, as well as everybody knows, that if we want to reside in this circle, we're going to be met with theories and observations that go against everything we believe in. And if we're going to put ourselves in a place where we're going to hear things that everything we know does not believe it, we're going to have to find a way to keep our understanding of the universe relevant to ourselves and in a place where we can reveal to those who are trying to tell us something that we understand just isn't true. It is 6:51 p.m. Central Daylight Time, 7:51 p.m. Eastern Time. This was the first show of Collision Course on Revolution Radio, freedomslips.com, Studio B. I want to remind everybody that Revolution Radio has always been a great place to come and hear free speech. We are living in a great time right now. Great time right now because things are getting done. Even when you look on the news or you listen to the radio, someone boo-hooing, somebody's smiling, somebody's happy, somebody's sad. You got to have it all to mean something's being done. When nothing's being done, nobody's nothing. When nothing's being done, there's no happy, there's no sad, there's just in between. I believe that this is a great time to get a lot of good things done. Why? Because there's a lot of people working. Not just working your job, not doing the 60 hours that we do every week, but coming home and putting in a little bit extra for your neighbor or for your community or for society. That's why I find being in science and astronomy to be so rewarding because, heck, I can call up Dr. Stephen Fuselier, even though he has to call up his friend Dave McComas to make sure that Francis is on the up and up. They'll do that. And they'll come back and they'll say, okay, I'm the science. Come and ask me questions. Come reveal what it is I have to reveal. He was a great guest. I didn't do it justice. I probably didn't do you all justice because this guy worked for Dr. Van Allen. Dr. Van Allen has a Van Allen radiation belts out there. This guy knows if spacecraft can actually go through that or not. I didn't ask the question, but that doesn't mean that we can't ask the question another time. We have to have a place of civil discourse before we can have a place of heated debate. scientists and scientists will surely shy away if all you have is a beratement of their ideas. You must have a discussion of reasonable and comprehensible understanding. So even though everything that Stephen is working on is setting us up for a new understanding about the universe, even the man doing the work is going to be probably the last one to accept what the truth is, only because he doesn't want to be wrong. So somebody can say, well, why don't you just ask him the question? Ask him the hard one. Let's just turn this whole thing into an electric universe conversation. And every you would have been hanging up. The number of you connected does not work anymore. And it will never work again in the future. So that's why we don't do it. What we do is we have the discussion, we understand what we're talking about, and we move forward, getting as much information as possible so that in the future, when the rubber meets the street, you can say, yes, we were part of that. We were understanding of that before. And of course, those who may have researched their electric universe and all this, for those who have done the research first and who have taken on the responsibility of stating that's what I believe in, well, then we have to give them credit that they were there first. And that's okay. Being there first doesn't mean that you're the only one there. Like Stephen said also, he said, I have to recognize the others that I work with. Without the team, there is no me. Without me, there is no team. Without team, well, I said that wrong. Without the team, there is no me. And I love calling the scientists because I get to pick their brain. And I look at conversation and conference calls as exactly that. When we get a group of great minds together, those great minds turn into one mind, and each one of the members in the conversation has the ability to access the greater mind just by asking the question and getting the information out there and discussing the topics. Well, we are getting close to the end. I am so glad that everybody showed up. I'm going to peek into the chat room. I've just... Good night, everyone. Peace out. Collision Course every Saturday night. Love you.
Radio at freedomslips.com, and we'll be right back after this message. Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at buyer risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps.